Okay, guys, this is part 11, and I almost ran out of time in the last video, so I'm just picking up right off where I left off. Okay, so we were talking about polarization. One of these objects is charged, and it is this little rectangle-looking object here. In each diagram, it's that rectangle-looking object, okay? And then the sphere is neutrally charged. So remember, polarization occurs when you have a neutral object and you have a charged object, and that charged object comes in close to the vicinity of that neutral object, and then the charges, or the electrons and the protons in that neutral object, will separate, okay, according to whatever type of charge is coming up to that vicinity. These little dots right here, they really are plus signs. It doesn't really come out that clear because it got a little pixelated when I increase the size, but just so you know. Okay, so diagram 1, is this the correct distribution of charges? Well, we have all the negative on this side, and we have positives on this side, and we have a negatively charged object here. So yes, this is correctly distributed. We have a positively charged object here, and well, since positive and positive repel, that is not what would happen. This is not correct. Those positive charges would be on this side because, you know, like repel and opposites attract. And again, here you go. We have negative and negative. This is incorrect. The negative should be on this side. Okay, this is correct, right? Because we have positive charges. They're attracting these negative charges, which are causing those positive charges to go to the opposite side. So yes, this is correct. This is incorrect. Why? Well, because this would have positive charges, the same number of positive charges as negative charges, on separate poles, on separate sides. So this picture is almost there, but not quite. So we're just looking at diagram A and diagram D as being correctly displayed, or depicting the proper distribution of charge. Okay, that was polarization, you guys. Okay, 31. The image below is an example of which charging mechanism? Well, this guy right here has, and this, I tried to do this in our lab on Thursday, and it just did not work out. I tried to get those balloons to hang from our ceiling, but I couldn't. But anyways, here's a picture of it. These balloons are being charged by friction, right? He's rubbing them on his head. So what type of charging mechanism? Friction. And explain what is occurring in each picture. Well, here, now that both of these have a negative charge, they are repelling. And he moves from the situation, and they, you know, are still repelling. And then, what happens is that polarization kind of occurs here. But since we have a positively charged head and a negatively charged balloon, this balloon now is attracted to that head. So you have attraction. All right. Be sure to include what the charges are for the balloon and the hair. So your hair at this point is positive, and the balloons are always negative. That's why they're repelling in all these situations until we come here. This is our last problem. The image below is an example of which charging mechanism? Well, let me think. This is induction. Remember, what is the, how do you charge by induction? Well, you bring a charged object near a neutral object, okay? And typically what will happen is polarization, because you can see that's what's happening here. And then you're able to remove that second object, B. See how we're removing it here. And since you were able to keep all the positive charges on the left in A and move those negative charges to B, you're able to separate them. And now you're able to say that this A is now charged. And the way that was done was through induction. This balloon was brought to induce polarization which is happening here, right? You have your positive charges moving to one side because they're attracted to that negative charge, and you have your electrons moving to the other side because they're being repelled by that negative charge, right? And now that they're separated, you remove this or you ground it. We didn't really talk too much about grounding, but it's just an excess of electrons that can come up to kind of balance stuff out. But anyways, don't ignore what I just said. I don't want you guys to get confused. So then they remove B, and A stays positively charged. And once, you remove the balloon from this situation, then those charges, since these are conductors, these charges will balance out within the material. Right? They're going to kind of go and sort of, all right, I have one here, and they're going to kind of separate. Well, why are they separating? Well, because they're negatives, and they're sort of repelling each other, but they can't repel so much because there's only enough space. There's only a certain amount of space to sort of go to their own little spot. That's induction. Again, this is probably going to be a problem on your exam. Maybe I'll say, what is occurring in diagram A? Is it induction? Is it polarization? Is it charge by contact? You could probably say, I probably wouldn't say polarization here because that is what's happening, but it's being induced. Induction. Charge by induction is what's happening. I'm sorry, that's so messy, you guys. Okay? Oh my gosh, that's it. Really? Done. I'm done. This is it. This is the last video for your final review guide, okay? Please, I've said this once, I'm going to say it again. Come and ask for help. If you guys are stuck, please don't wait until the last day, Tuesday afternoon, I'm about to leave, and you come and ask for help. I mean, of course you can come in then when that's your only option. But if you have questions now, email me. Send me a remind. You can comment on those reminds if you have questions, and then you ask a question and everybody gets the answer. Come and see me before class, during lunch, after class. Come and see me before school or after school, anytime. Okay, you guys? And I know you're all going to do fabulously. And then just think, 4 days from now, we're going to have a nice summer vacation. So remember, all this work is worth it. All right. Have a great weekend. I'll talk to you guys tomorrow.